All right, welcome to 4.2, congruence of triangles. First off, if two figures are congruent, they're going to have the same shape and the same size. And these three quadrilaterals are all congruent. And over here, none of these are congruent. So notice this triangle and this triangle, they have the same shape but not the same size. This pentagon and this pentagon do not have the same shape or size. That this angle is not congruent to this angle. These are what we call corresponding angles. This angle would correspond with this angle corresponds with that angle, and we also have corresponding sides, like this side and this side correspond. But since this angle and this angle are not congruent, these shapes are not congruent. And two figures are congruent, then their corresponding angles and corresponding sides are congruent. So all their angles, all their sides. This definition is going to become very important later on in this section. We'll be using that quite a bit. So, in this first example, triangle ABC is congruent to triangle XYZ. Notice angle A, when we write these congruent statements, has to match up with angle X. So angle A is congruent to angle X. Angle Y up here, the second letter, has to match up with the second letter, B. And C and Z match up. Okay. Not only do those angles match up, but we could look at sides, like side AB. The first two letters have to match up with the first two letters, XY. So AB matches up with XY. Now this one's a pretty straightforward question, but it becomes more important when you start to rotate a figure. So for example, I'm going to move this, but if I spun this figure around, these triangles are still going to be congruent. Okay, the angles and stuff are not going to be in the right spots anymore. But we could do the same thing. Angle A corresponds with angle X, and now angle X is this angle now once we rotated it. So you got to pay attention to these congruent statements and make sure your corresponding parts are matching up. Okay, so we already kind of listed this out, but in the book they're going to ask you to name all the corresponding parts. That's going to be 6 things. Okay. Corresponding angles are like angle A and angle X, angle B and angle Y, angle C and angle Z. Corresponding sides, side AB, and AB we said matches up with the first two letters XY, the middle two letter, BC, and YZ, and CA, the first and last letters make a side, match up with the first and last letters CX. Here we got example 2. This time we have congruent figures that are quadrilaterals, and they want us to solve for X and Y. And so what we want to do here is pay attention that, I don't know if this will work or not, but notice that, they're grouped together. This figure is not going to sit right on top of this figure exactly. We're going to have to actually spin this or flip it or do something. So it's really nice to have this congruent statement, knowing that angle A matches up with angle K. This angle matches up with angle K. But that doesn't help us. We want to know about angle H. What angle matches up with H? H matches up, that's the third one in, matches up with C. This angle and this angle are congruent. And now I can use that to write an equation. I can say 5y minus 12 equals 113. Add 12 to both sides. 5y equals 125. Divide by 5. Y equals 225. Excuse me, 25. And now we also need to solve for x. Skip that one. And as we solve for x, over here I have two statements with x in it. Which one do I need to use? Well, the only side length that I know about is AB. That's the only side I know. So I need to figure out what side corresponds to AB in the figure. So here's AB, first two letters. I'm looking at first two letters KJ. So the corresponding side to AB is KJ. So I know this side length has to be the same as this because the corresponding sides are congruent. So I have 4x minus 3 equals 9. So 4x has got to equal, I added 3, so I get 12. Divide by 4, x equals 3. So now I have x and y solved for. Third angles theorem. It's a nice little formula. It says if two angles of one triangle are congruent to two angles of another, then the third angles are also congruent. So I look at this. I know this angle is 92 degrees, that angle is 92 degrees. By definition of congruence, if they have the same measure, they're going to be congruent. So I have one set of congruent angles. Do I have another? And hopefully you look at this and say, yes, you do. We need to be able to identify vertical angles and see that those are congruent. We're going to run into this a lot this chapter, using the vertical angles theorem to get a set of angles congruent. So this angle is congruent to this one, this angle is congruent to that one. What do we know about our third angles? Well, by the third angles theorem, these two angles would also have to be congruent. So now the question is, determine whether the triangles are congruent. Do all the corresponding sides, are they all congruent? Are all the corresponding angles congruent? And we look, these are my congruent tick marks, and those match up, and the corresponding angles match up. So determine whether triangles are congruent. I'm going to say yes. Triangle. I'm going to pick one triangle and write a statement. It's kind of nice to go alphabetically. So I'm going to go RST. You don't have to go alphabetically, but it makes it a little bit easier to check your answer. So now R corresponded to the one with the third angle. So R corresponded with V. S corresponded with U. Try to make sure you make your U's and V's different. And T corresponded with itself, right? So I get that congruent statement. Okay. Last example here, and then there are a couple other properties, but we want to show that triangle AEB is congruent to triangle DEC. We want to show those triangles are congruent, and we're given a few different things. So I'm going to start this by saying AB is parallel to DC, given. 2, what can I conclude from that? If AB is parallel to DC, I know this set of angles has to be congruent. Okay, so I'm going to say angle BCD is congruent to angle. This angle's got to be congruent to that angle. ABC That's the alternate interior angles theorem. Remember, the theorems show angles are congruent. The converse show lines are parallel. Now, also using the alternate interior angles theorem, this angle has to be congruent to that angle. Okay, so I'm going to include that in there. Angle BAB is congruent to angle CBA. All right, so we got two angles congruent. Now I need to show my third angles are congruent. And we have two options for a reason for that. Why is this angle congruent to that angle? Angle AEB congruent to angle CED. Like I said, we have two options. Those are vertical angles, but we could also use that third angles theorem at this point. So I'll write vertical angles. We'll be using that one a lot. There's supposed to be an E in there. It kind of got blotted. And so we get now, I'm going to change colors here. I have one angle, two angles, three angles. So I showed three parts are congruent to three parts, but I still need to show three sides are congruent to three sides. So I'm given one of those. I'm given AB is congruent to DC. That was a given. And I'm left with one more given, that E is the midpoint BC and AD. That was given. Now I should be able to finish this up. So I have one side here, and now I can use this statement. E is the midpoint of those segments, so what do I know about those segments then? If it's a midpoint, the definition of midpoint says it divides the segment into two congruent pieces. So I know AE is congruent to ED. AE congruent to ED, and BE is congruent to EC. So that's a second side and a third side. And the reason for this is definition of midpoint. Feel free to study your flashcards, that should help. Now I have enough to say triangle. What were they having us try to prove? AEB congruent to triangle BEC. And what the reason for this is going to be definition of congruent figures. Right? Definition of congruent figure said if all the corresponding parts were congruent, the figures are congruent. Okay, parts being the sides and angles. The last two things, we're going to be using these later on in this. Well, we'll use them in the homework today, but we'll use them again later on in sections. But reflexive property, everything's congruent to itself. Symmetric property, a triangle. If triangle ABC is congruent to triangle DEF, symmetric property would say then triangle DEF is going to be congruent to ABC. right? You flip the order. Transitive property is you go from triangle 1 is congruent to triangle 2, and triangle 2 is congruent to triangle 3, then triangle 1 is congruent to triangle 3, right? You skip over. So I kind of shorthanded it, but we've done a lot with that stuff in other sections, so hopefully you know those. There's your homework.